Hello, this is David Birch at Starpath School of Navigation in Seattle, and I'd like to show two things. One is a very nice new feature of the Ocean's Grid Explorer and WeatherNet services they offer, which now has scatterometer data as grid files. And to illustrate one of the things we can do with that, which is namely compare tropical or any wind system forecasts from one of the models with the actual wind measured with a scatterometer. And the example I use here is this this storm here, tropical storm Claudette from a couple weeks ago off the East Coast. And this is the view of it here. This is a forecast from the Ocean Prediction Center. Not a forecast, surface analysis map. 12 Zulu on Bastille Day, it looks like here, 7/14. So this doesn't look like much right here. That's the area we're going to look at. And then here is actually, though, the note they put, which should catch our attention: a maximum winds, a tropical storm, TS Claudette, maximum winds 40 knots, gusting to 50. And then they say, see the advisories from the National Hurricane Center. That's obviously good advice. And also, it's called TS, Tropical Storm. This is clearly not in the tropics anymore. It must have started down here somewhere. But here then you can go, and then you can stop this video to come back and look at these actual web pages here. This is the storm forecast from the National Hurricane Center, and you can get these online with an email request to SailDocs, for example. One way to get them. And you see here is their report, maximum winds 40 knots, and the central pressure. Look, the pressure didn't get real low on this, 1,005 millibars. And then they say the storm is moving toward the northeast, or, well, 045 or 050 at 18 knots. And then some further forecasts. The other maps that the National Hurricane Center offers, which are harder to get when you're offshore, the other one you can get just with a text report. This one is a little, you have to, we have some books that explain how to do this, but I'm not going to cover that now. But this graphic here shows the distribution of the winds in that system that were predicted on the 13th, the day before we were looking at that map. The other types of maps that they show, this shows a probability that it actually gets up to 50 knots of wind, 1 minute average over 50 knots. And you see that's still pretty small for this system, 5% all the way in its whole history here. And for a while here, for the next day or two, you still have like a 20% chance of getting 50 knots. So that is that's the storm we're looking at. And you see, back to here, you don't get much information from this, but, oh dear, where do I get, I gotta get over to here. Let's see if that's still running. I'm running on a Mac, and the program I want to use is a Grid Explorer version for the Windows. So this is a Windows machine running inside a virtual machine of a Mac. And so on the left here, on the left, we have the GFS forecast, global for the grid winds that you could download for this period of time, and for 5 days more or something. But the time, the valid time of this, which is this is the base map of this forecast zone. So this is the same as a surface analysis, effectively. And this is July 14th at 18 Zulu. 18 Zulu. Now over here, this is really a coincidence in the sense that we have the ASCAT satellite going overhead of that zone, and we have good data from the satellite at about just 2 hours, 2.5 hours later. So this is a pretty reasonable comparison. But this is the new feature they offer. The GFS is standard grid file winds. You can get that on many programs from many places. But then Grid Explorer has this nice feature that I can set up this two-dimensional route, which you do with this tool here, right there. And then that's this tool. And then this is showing me, this plot over here is showing the wind speeds all along this route. So you see I'm coming down the road, the wind's picking up a little bit, then we go into the sort of the eye of the storm, and then it comes back to 0. Watch this little cursor over here. And see, I'm going in the eye of the storm. It's weaker. And then going back up the other side, that is the so-called dangerous side of the right-hand side in the northern hemisphere. And the winds are stronger. They go up to about, looks like almost 30 knots here, about 30. They show 30. And it's stronger because the storm's going that way. I mean, the winds are rotating this way and the storm's going that way, so these winds add. And whereas these winds subtract, the motion of the storm diminishes the winds here and so forth. There's other reasons why this is dangerous. In a sense, the so-called dangerous side of the storm is because these winds, if you're up here, are pushing you in the direction of the storm. Whereas if you're on this side of the storm, the winds are pushing you away from the storm. So that's really, in a sense, the reason why it's dangerous. But now look at the trick you can do. We got this route here. So I can just take this and I'll watch the graph over here on the left as I sweep this around. So this is a way I can kind of sniff through the entire storm and storm system and look for the peak winds. So you see they're peaking out about 30 knots, maybe a hair over 30, but that's the forecast from the global forecast system, 30 knots. The global forecast system did not have a chance to read. It didn't do anything. It's just a computer telling you what it thinks it is. It didn't read the National Hurricane Center. It said there's 40 knots going to be there, right? Not 30. So if you've got a boat and you're just using this, you're thinking you're dealing with a 30-knot system, and that's all you see. No matter where you are in that system or how big your grid or what you zoom in, you're only seeing 30 knots, maybe 30, maybe periodic, maybe 131 or something like that. Now, however, let's go and see what was really there. Now we can go here. Whoops, this thing moved on me, but I can just drag this over here and drag this over here. Now we can do the same. Is this going to be the same? Yeah. So now let's look at what this is the actual storm. These are winds measured by the satellites going by. So it's not a forecast, not a prediction. The actual winds that were measured as the satellite went by at 2050, just 2 hours after this. And then, so now we go through here and look at the scales changed over there. Now look at that. We're banged up. There's your 40 knots, 41 knots. Right? So somewhere in that system, I don't know exactly where, till you can move your cursor around here and click and read all these winds individually, digitally, but to just in the sweeping pattern here, the main thing I want to show is that the actual winds were 40 knots, a little over 40 knots, just as a Hurricane Center predicted, but not as a GFS predicted. And that's the main message that I wanted to make with that video. First of all, to show how beautiful this kind of vectorized presentation of this data is. And second of all, we're using it to confirm something that we've taught a long time, that you should not rely just on the GFS when you're evaluating your weather maps. And that's it for now. Thanks. Bye.